And finally, I want to review the different types of controllers there are and the function of reset before finishing up this module. I'm going to have the next section of notes is on how to tackle complex designs. And there I'm going to cover my fourth and final mantra, and that is clearly separate data path from controller. And here I'm just summarizing what I'll talk about more then, and that is that there are different types of controllers, finite state machines and hierarchy of finite state machines, and I'll talk about this a little in these notes. And in that section of the class, I'll talk about pipeline finite state machines and counters. So in general, most chips are too large, or the effective finite state diagram is too large to have only one finite state machine. Once the finite state machine gets large, and that depends on your clock frequency goal and the technology and so on, but it tends to get slow. And thus you end up having a hierarchical controller. We have some sort of master finite state machine that's producing sequencing events to smaller finite state machines. This is producing the high-level sequences, that is major steps taken within the chip or major different types of control strategy. And this is producing the detailed sequences out to the control lines at the bottom here, which are going to the data path. So you might have to partition up a large finite state machine into many smaller finite state machines in a hierarchical fashion in order to effectively implement a large and complex state controller. And finally, I want to remind you of the role of reset. Reset is a global signal that the designer cannot modify. The way it usually works is on power up. There's a detector that detects that VDD has exceeded a certain point, and at that time it initiates a reset. Sometimes you might have an additional reset, a hard button, or a reset interrupt. The purpose of reset is solely to get the machine into a known state. It's not for local control initiated by the designer. It comes from outside the design, and it gets the machine into a known state. You're all quite familiar with the idea of having to turn off and turn on your various electronic devices in order to recover from some otherwise irrecoverable state of the machine. Well, what you're doing exactly is getting it back into this known state by doing a power on reset. It has to go to every register in your machine that determines that state. What those are up to the designer, but it will include all finite state machines, and that's the thing I want to mainly emphasize here. But in addition, some of your counters that are used in the controller might have reset going to them, as well as some status registers that contain various flags produced by the design. So this brings us to the end of this entire module. The Moore and Mealy Verilog is quite different in terms of its output logic, and thus different in the coding. I generally suggest using a Moore machine because you can constrain the paths from inputs to output. You won't have unconstrained timing paths, but the Mealy machine can be faster in certain circumstances. And I'll remind you that reset is a golden external signal used to get the finite state machine into a known state. I now suggest you do the next submodule quiz before going on to the final quiz for this finite state machine section. Thank you very much.